So having covered the basics of programming, now let's actually jump into how to make a game with Godot. And you're going to see a lot of different tutorials out there on how to make this game or that game. I think the better way to cover Godot is to talk about what the different components are of Godot and how they work in games, and basically walking through like the structure of a Godot game and the specific nodes of Godot. So we're going to cover just some of the basics today of how a Godot game is set up, and that's through scenes and nodes, and some specific, really basic nodes, including bodies, colliders, sprites, and meshes. So just to go over what you should know so far, you should know how variables work in programming, so declaration and usage, some of the different data types of variables, things like ints and floats and structs, that sort of thing, and then also for structs member properties. You should also know about functions and how functions can take in arguments and return values. And you should know about classes and objects from the object-oriented programming video. So that would be properties, member methods of classes, and how inheritance works. So if any of this doesn't sound familiar, go back and watch the Intro to Programming for New Video Game Devs series, and there's 4 different videos plus an exercise video. So go back and watch that series or watch the specific videos on these different concepts if any of this does not sound familiar. Hopefully you're up to speed on at least the concepts of these things. If you are, that means you are ready to get started with Godot. First, we're going to talk about a new data structure, and that is the tree data structure. Now, you don't really need to know the implementation details of this, but a tree is just a mathematical data structure, and of course you can implement a tree in code. But basically what a tree is it has a root node with 0 or more child nodes, and then each child node itself can have 0 or more child nodes as well as a parent node. So the root is the root of the tree. It doesn't have a parent node. But then any one child node will always have a parent node, and it can have 0 or more child nodes. And then the nodes at the end, those are typically called leaf nodes because they don't have child nodes. And the reason this is relevant is because this is how things are set up in Godot. Godot uses the concept of nodes and a tree of nodes, the hierarchy structure of this. And you'll see that we can't have one node that kind of attaches to its sibling because that's not how a tree works. You can have this sort of depth, but you don't have a lot of or you don't have any sort of cross connections. It's just straight up and down as a hierarchy. So in Godot, we have what are called scenes, and one scene is really a scene tree. And when we talk about scenes, what we're really talking about are typically reusable game elements. So like the main character might be its own scene, a level might be its own scene, reusable items might be their own scene, all sorts of different things that you can reuse will be scenes. And so the word scene doesn't necessarily mean like a scene in a movie or a scene in a video game where it's, here's this environment and here are all the different components of that thing. Although that is what we might call like a level, and a level might be a scene. But we also use scenes to make up other things like individual items or characters or other things like that. So the scene is a tree of nodes, or it's a hierarchy of nodes. So for example, we might have a character body, and the character body might have a sprite and a collision shape. And then in the world, we might have that as our character, and then we might also have scenes for the floor or the walls. We might also include other types of nodes, like if there's animations and animation player, all sorts of other nodes. Okay, so When we went through object-oriented programming, we talked about inheritance. And the reason that's relevant is in Godot, all nodes inherit from a base node class. So the node class includes abstract member functions of ready, process, and physics process. And it's got some other ones too, but those are the three that you're going to probably be using a lot. So these are just abstract functions. If you implement them, Godot will call them, but if you don't implement them, then they just will sort of be passed by. And it's important to note that it's the engine that calls these functions. We define them in a script that is attached to a node, but we, as the programmers, we never call these functions. Instead, it's the engine that calls these functions at appropriate times. So all nodes are going to have these three functions, and they're going to be called at the appropriate times. But for some nodes, when you don't add these functions, they just sort of get skipped. So this function, the first one, ready, this is called once, and it's called when the node is added to the scene tree during gameplay. So this is sort of like your initialization. It's like, okay, well, when this node gets added, I might want to initialize some values, just kind of set things up, and now it's ready to go. And that's the only time that that ready function is called. Now, games operate on a series of frames, and there's display frames, there's processing frames, and then there's physics frames. So we don't need to worry too much about the display frame rate. That's kind of taken care of by the engine. What we care about is processing frames and physics processing frames. Processing frames, this is going to be called as fast as possible by the engine, which means if you have a really, really powerful computer, this might be called many, many times per second. Or if you have a very slow computer, it might only be called a few times a second, and you're going to have a really laggy input. Basically, this is saying to the node, what do you want to do right now? So based on the state of the game and based on what input you're getting, based on all this stuff, what do you want to do? So the game is going to try, or the engine's going to call process as fast as possible. Now you might think, well, that's great, I'll just put everything in process. But consider that if you have a really, really powerful system, that might make the player move really, really fast. And if you have a very low-powered system, it'll make the player move really, really slow. So when we're doing movement or physics-related things like falling or physics interactions where forces are interacting with objects, we want to use something that's at a fixed frame rate. And this is called physics process. So basically, if you are doing something that has to do with movement, it's good to do that in physics process. If you're processing input or doing other stuff, it's good to put that in process. And in a future video, we'll show how you can commingle these things. For now, we're just going to kind of only look at physics process, just because that's one of the defaults that Godot gives us. But in the future, we will talk about how to separate this out and sort of use these things together. So nodes themselves are the fundamental building blocks of your game. So they're sort of like individual Lego pieces where you want to know how this piece works, how it fits together with other pieces. But at the end of the day, one building block gives you one piece of functionality. Okay, so what are some types of nodes that we get? Well, one of the most basic is bodies. And there are three kind of classes of bodies. There's static bodies, which, as the name says, these are intended for things that aren't moving around. So things like walls, floors, ceilings, static objects like maybe light poles or just obstacles in your way, that sort of thing. Then there's physics bodies. These are intended for objects that are to be moved through physics. So if you were making like a baseball game or a sports game of any sort, balls or projectiles in that game you would probably model with physics bodies. Now, we typically don't use physics bodies for input character controlled entities. Instead, we have what's called the character body. Other engines might call this the kinematic body. And in fact, Godot, earlier versions of Godot used kinematic body. But basically, this is intended for script moved objects. So, like the player, like non-player characters, scriptable items, other things like that. So, keep this in mind. This is kind of the rule of thumb. If it's just going to be something that's standing there and not moving, use a static body. If it's something that you want to be controlled through physics, but you don't want the player to control directly, consider using a physics body. And if you're having the character or something else that you want to be moved through scripting, you can use a character body. Now, the body only defines how this thing, the scene, moves, if it does at all. It doesn't define its shape, doesn't define what it looks like, and it's basically just a single point in space. So let's look at some of the specifics of rigid body. The static body, it doesn't really have a lot to it. It's just sort of a container for other things. So some of the functions that you have access to through rigid body, these are moved by interaction with other objects or applied forces. So you can use them as a player controlled thing by applying force to them. Or if you just have things colliding with each other or gravity or whatever else, these things will just sort of move on their own. So things like add constant force, this is a member method of the rigid body. So you have to pass it a force and where the force is positioned, so a position value. Now a constant force, this is a force that's applied over time. So think about hitting the accelerator in a car. The car isn't going to instantly jump to 60 miles per hour. It's going to take some time to get from 0 to 60 miles an hour, and that's because there's a constant force being applied to the car. Now, by contrast, because we're in the video game world, we can do something that you can't do in the real world and apply a central impulse force. Or if you think about like hitting a baseball with a baseball bat, it's not instant, but for all intents and purposes, it's an instant impulse force. There's this collision, and all of a sudden the ball is, suddenly moving in a different direction. So forces are all about movement, like in a line or in an arc. Torque is about spinning. So you can apply a torque to an object as well. Rigid bodies have the ability to detect collisions. So you can say get colliding bodies and you'll get an array of node 2D objects. And so you can sort of look through them and see, what am I colliding with? And, you might need to do that to figure out how to act. Now, one more thing is that calculating forces acting on a rigid body can be pretty computationally expensive. So many rigid bodies will have the ability to sleep, which means don't calculate any forces on this thing unless there's some interaction with it, unless it hits something. Now, for really important objects where, maybe this thing is flying through the air, if you're making an archery game or something that's heavily driven by physics, you might want to not let the arrow go to sleep. But otherwise, just keep this in mind that by default, this is set to can sleep, and then it'll go to sleep after a period of time. So if your physics objects are behaving strangely, you might want to start there, and you might want to override it. Now, character body, again, this is kind of what we use for most characters or player character things in the game. So this is script controlled, and we can have other interactions on this, but we have to detect it and put it into the script. So you can set the velocity. You can sort of simulate forces on this as well by calculating velocity changes over time and using the frame rate to kind of figure out what you want to do. But it's intended to be used as just setting the velocity or manipulating the velocity generally. Move and slide is the method that is called to say, okay, now that the velocity has been set, move accordingly, and you put that in the physics process method. And character body can also detect collisions, but usefully it can detect things like is on ceiling or is on floor or is on wall. And basically, so for is on floor, for example, you can just say, if this body is on the floor and you get a jump input, then jump. Another thing, get last slide collision. You can see what the last thing to have collided with this body was. And if it's colliding with some wall, you can get the wall normal. So a surface normal is basically like, what's the direction away from that thing. So if you're going to simulate like bouncing off of the wall, you can just reverse around the normal. Okay, so that's about bodies. Now let's talk about collision objects. So like I said before, bodies in Godot are just a single point in space. It doesn't say how this thing can collide with other things or where its shape is. And so if you've heard about games like the colliders for games, like in fighting games or in Dark Souls or action games where, the collider doesn't really fairly match the shape that you can actually see, like the visible shape. Those are two different things. So the collision shape is a collider, and that's what triggers the physics engine to understand, these two bodies have intersected, they've hit each other. So a collision object defines the collidable shape of the body. So when you're playing the game, the collision object or the collision shape is hidden, although you can enable debug mode in Godot and you can see it when you're running your game in debug mode. So there's two types of shapes. There's simple shapes like circles or rectangles or capsules in 2D, and then things like spheres or rectangular prisms or cones or cylinders or capsules in 3D. Then you can also have complex shapes where you define it. And so there's a collision polygon, and Godot actually gives you the ability, if you have a mesh, it can automatically calculate the collision polygon for you. So that's pretty nice, but using collision polygons typically is going to be very computationally expensive. So try to use simple shapes where you can. Circles are absolutely the easiest. You're just looking, hey, at the center of this thing, or is there something else within the radius of the circle? Is there another collider within that? And if so, it's collided. Like, that's super easy. So rectangle, capsule, these are a little bit more computationally expensive, but not nearly as much as collision polygons. Okay, so how do we make nodes visible since the body is not visible and the collision shape is not visible? Well, for 2D, we have a sprite 2D. A sprite is just an image, so you can import an image that moves with the node body. So if it's a node that is a sprite 2D that is a child of the character body, for example, as the character body moves, the sprite 2D moves with it. So we don't have to manually say, move the sprite. The whole thing, the whole scene moves together. Godot also gives us an animated sprite 2D, and also the sprite 2D can have multiple sprites in it. So there's just different ways of animating the sprite, but basically all an animated sprite is having a series of different sprites that are played back over time. So just like a movie has frames that are played back very rapidly, sprites can have multiple images that are played back rapidly over time to simulate movement or animation. As another example of ways to make something visible, we have a mesh instance node. So the mesh instance, this is if we want to do something more complicated. You can like give it an actual material, like a physics material to simulate. And then that can be defined in Godot, or it can be defined in something like Blender or somewhere else, and you can import it. That's a way to give it just a color or something. So these are just two different ways to make your body visible. Okay, so how do we set this up for a character? Well, we start with the body, probably a character body, and then under that we give it two child nodes. We can give it a collision shape, which might be like a capsule shape, and then we can give it a sprite shape that is also a capsule shape, and then we can just, or like a mesh instance that it has a capsule shape, and we can make those two things perfectly overlap. So that's like the very simplest way to make a character. So let's actually do that in a new Godot game. So here I have Godot. Okay, and this is what pops up. So this is sort of confusing the first time you look at it. It's like, what's going on here? But this is Godot. This is the editor. Now, so what we're seeing here is a 3D space because we're in the 3D mode. Now, for this video, we're going to do both a 2D example and a 3D example. So to start with, we don't really want to be in 3D. We're going to do a 2D. And so you can see here in the 2D mode, this is like a 2D grid. And you can see that here's this intersection. So this red line is the x-axis. This green line is the y-axis. And the way Godot works, at this origin right here, x values increase going to the right. Y values actually increase going down. So this blue rectangle, this is what our camera would be in this game. And this is just the default camera without adding a separate camera. So if we just run this, let's go other node. We'll do node 2D, create, and we'll just say this is world. Okay, so we'll say select. We'll save this first, world, then run, select, world, open. Okay, so nothing's really going on here, right? But we haven't added anything to the game, so that's what we should expect. So all we've done so far is just made a world, which is a 2D node, and 2D nodes, you can't see them, you can't interact with them, they just sort of exist. So this is just our anchor for our world. But instead of doing that, let's make a player. So like I said, for a player, we're going to start with a character body 2D. So let's do this, and we'll say player, and we'll save this, and we'll say this is the player scene. So we'll say save. Okay, so now we have a new scene that is our player. Now the thing is, this is our blue rectangle for the camera again. That's just there as part of the editor. It doesn't really mean anything for our actual scene. So we can zoom in. This is where the character body lives right now. It's just this one point. You can see it comes up as player if you hover over it with the mouse. And over here, we're getting this warning. So let's check that out. So node configuration warning. This node has no shape, so it can't collide or interact with other objects. Consider adding a node or collision shape 2D or a collision polygon 2D. So let's do that. Let's say add child node, and we're going to search for collision shape 2D. Now we add that, and then we get yet another warning that says a shape must be provided for this collision shape to function. Please create a shape resource for it. Okay, so what this means is collision shape 2D, this inherits all the way from the node class, and it's sort of a series of different dependencies, and the actual shape of the collision shape is a property of this object, so a property of the class. So for for Godot, on the left side over here, this is our scene tree. This is our hierarchy of nodes. And so we've got two nodes. We've got a character body 2D and a collision shape 2D. But if we want to access the properties of one of these things, a property of the object, then we have to look over here on the right in what's called the inspector. So in the inspector, you can see there's this shape, and this is the actual shape owned by this collision shape. And right now it's empty. And that's what this warning is telling us. Please create a shape for this thing. So let's use a capsule collider. So we're going to say new capsule shape. And a capsule is basically like a cylinder, kind of. It's like a rectangle with rounded ends. So you can see that. That's what a capsule looks like. And if we want to change the shape of this, we can either go right here and click on it. We can change the radius and the height, or we can just use these little tooltip things and change it right here. So make it whatever you like. I'm just going to go 20 and 70 just so I can remember the values. So this capsule shape is itself also a class, and so this is the properties of that class, and they have defaults. So if you want to reset the defaults, you just hit the reset button. So that'll reset to nothing, which is the default. Then if I say capsule shape, right now it has the default radius of 10 and the default height of 30. So I'll change that to 20, and then I'll go 70. And so now I have changed that away from the default. So if you wanted to reset the defaults, you just hit the reset button. If you want to set them manually, you set them manually. And if you want to set them with your mouse, set them with your mouse. Okay, so now we have a shape, but again, if we run this, the shape is not visible. Now we can say, if we go up here to debug, we can say visible collision shapes. And so then if you were to run the game with this thing, then you could see it. But instead of doing that, let's add another child node, and we'll go mesh instance 2D. And what is the mesh? Again, we have to say new capsule mesh. And then, so this is all in meters. So let's zoom in. You can see it's much smaller. Oh, and if you hold down Alt, then it'll mirror around the axis. So we'll go as wide and as tall. A little bit wider. There. So now you can see these eyeballs. Right now they're open, so they're visible. If you click it, it'll toggle it so you can't see it. The other thing you can do is drag the nodes around to change which one is on top. So these don't match perfectly, but they're pretty close. So I'm okay with that. Let's see. Oops, I want to go collision shape. Let's see. I don't know if I can get it any better. It's pretty close, so that's fine with me. So I'm going to move this one down just so that I can see this a little better. And for Godot, in our, let's see, in our visibility, so you can actually see the entire node hierarchy inheritance right in this panel. So you can see the mesh instance inherits from node, which actually is canvas item inherits from node. Node 2D inherits from canvas item. Collision shape 2D inherits from node 2D. So any of these properties or methods of any of these things will be included in the mesh instance 2D because of inheritance. So one of the things that is provided for a canvas item is these modulate and self-modulate. So if we wanted to make our character say green, for example, we can change the self-modulate, and you can see right now the values are at full white. So if I drag down the red and if I drag down the blue, then I'll get sort of a very bright green. to actually modulate. Okay. Oh, did I change the wrong? Oh, that's, yeah, okay. I was changing the wrong thing. All right, let's go mesh instance. Now that's what we want. Okay, self-modulate. Okay, that's what we want. And then I'm gonna make it a little bit darker just so it's easier on the eyes. Great, so now we have a little green character. Now, this doesn't look like much, it would just be placeholder art, but at least we can tell, because it's green, we can tell that, oh, this is our player. The good guy is green, right? Now, it's not in our world yet, and that's because we need to add an instance of a child scene. So let's do that. So we're going to instantiate child scene, and we'll say player, and here comes our player. He's right there. So we can put him right here in our game. We'll save, and then we'll run, and you can see there's the player. Now, right now, we can't do anything to the player. We can't move him around. He's just kind of hanging out, sitting right where we put him, because we haven't added a script yet. So let's do that next. So actually, I'm going to move this up a little bit. And the first thing we can do, we'll go back to the player. And all I'm going to do is attach a script, hit this, and then create. And you can see that for the character body 2D, there's already a script built right into Godot that will allow us to move this player around. So this gives us speed and jump velocity, and so if not is on floor, then velocity plus equals get gravity times delta. So this is going to add gravity, and so the player will fall if he's not on the floor. If we are on the floor and we hit jump, which in this case is this UI accept action, we'll talk about that later, then the player will jump. Then if we get UI left or UI right, we're going to get an axis. That's just a direction of movement. That's going to be multiplied by speed, and then that'll cause the player to move. So let's save this, and we'll go back to our game, and we'll run it, and he should just fall right off the screen because gravity is affecting him. So if we run it one more time, we can sort of move him around right before he falls off the screen. So the problem here, he falls off the screen because there's no ground. There's nothing for him to collide with. So we need to add a static body. So what we're going to do is we can add a child node, and we'll say static body 2D. And then again, we get this same warning. Oh, this has no shape. Give it a shape. So we'll say collision shape 2D. Then over here, we'll give that a rectangle shape. Now I'm going to move this whole thing kind of right into the middle. And then I'm going to take our, I'm going to give this whole thing, this is going to be our ground. So right now, this is a collision shape for the ground. I haven't given it anything that'll make it visible. So if we run our game, you can't see the ground, but you can see that we're on it. And now that we're on the ground, we should be is on floor. So if we hit space, which is our UI accept, then our player jumps. Cool. All right, so now let's make it clear that the ground is actually there. So let's give it a mesh instance. So we'll say mesh instance 2D. And we'll give it a new box mesh. And we'll say, make it the same size, like that. And then since this is the ground, let's go visibility and modulate, and we'll go take out the blue, give it kind of an orange, almost kind of brown color. I'm gonna just make this just a little bit bigger, just so it kind of goes off the screen. It's more, okay, right there. So now let's run this, and you can see we're now running around on a visible ground. And if we wanted to give this a sky, like a sky background, we can take the world, add a child node, mesh instance 2D. Now we can say, let's name this ground. Let's name this sky. So we're gonna say this is a box mesh. We're just gonna have it come right over there, right over here, and then down. Now and then we'll say visibility, modulate, and we'll drag down the red, drag down the green, give it a nice sky blue. Now you can see it's covering our ground and it's covering our player, and that's because things are ordered or rendered in order of the Z direction. So to change the Z direction, we can just drag this up and put it behind the player and the ground. And so now we can actually see our player. I'm gonna make it just a little bit bigger than the camera just so that it doesn't show just some weird gray. Okay, so now we can see we're able to move around. Cool. So that's the basics of the character body, collision shapes, and mesh instances or sprites. Now let's say instead of this capsule shape, we wanted to actually use like a sprite for our player. Well, what we could do, let's just knock out this mesh instance 2D. I'm gonna reset that. Now let's go add child node sprite 2D. So now we have a sprite 2D. Now you can see over here, we can't see anything yet because we haven't given it a sprite. Again, we need to set the property for the sprite. Now every Godot game comes with this icon.svg. We can use that as our texture. So I'm just gonna drag that right into the texture, and we get this Godot robot. So I'll make that the same size as our collision shape. And it's kind of funky. But if we go over to our game now you can see we've got the little Godot robot running around. Cool. So that's how we could use a sprite instead. And the real thing you would do is go find a sprite you want and import it right over here. You could like create a resources like sprites folder and then drag it into there. What this icon is really used for is if you were to export this game to an executable file, that would be the icon for the file that shows, like if you put it on your desktop, that would be the icon for it. And you can change the icon. So you can just look on the Godot resources of how to do all that. So speaking of that, to learn what all these different functions are that are available, you can use the documentation for Godot, which is right on the docs.godotengine.org. And just, I mean, if you just go right to there, then you can see this is the documentation. And so we can go to class reference, nodes, and then you can see all the different nodes. So after watching this video, I highly encourage you to go read Character Body 2D. Just read all of this and look through some of the different methods that are available. Also read up on the collision object, and then Physics Body 2D, which would be Character Body 2D. Just kind of read through all this stuff. Some of the stuff won't really make sense for a while until you've been doing some of this, had some experience. But reading the docs is a really good way to sort of get some of this knowledge in your head. So read about the collision object and the collision shape, and also read about the static body, which is all the way down here. So static body 2D, you can see all this stuff. And then also read about the rigid body. We haven't used a rigid body yet, but see if you can add something into the game with a rigid body. Okay, so this is what an example character looks like. So now with the scripts, so we've already added a script to our player. You can attach one script per node, and this is how we get separation and single responsibility principle. If you need multiple scripts, it typically means you need to attach them to different nodes and have them do different things. So the script extends the node class that it's attached to. So that means that within your script, you can access any of the node's properties and methods. So like I was showing in the hierarchy here in Godot, if we go back to our player, and on right here on our player, any of these different properties, you can see them in the inspector. So you can see, you know, all these different things. So like the visibility, the modulate. Let's get rid of this. Change it back to mesh instance. We'll do capsule. Okay. Let's make him green again. Oops. Okay. All right, so that's our, so if we wanted to, we could actually get a reference to this mesh instance and the modulate value and change it through our code. And you've got all these different things in here. I'm not going to go through them all right now, but just understand that anything that you can see in the inspector, these are properties that you can access in the code. So let's jump into our script, and then let's look at, let's say, floor, stop on slope. So this is a Boolean value, stop on slope. If true, the body will not slide on slopes. If false, the body will slide on slopes. So if we wanted to, we could say, remember that func ready, we can say stop floor stop on slope equals false. Now, right now it's true, but what would happen is, because this hasn't actually been added to the scene tree yet, because the game's not running, as soon as the game would run, when this would be called, then as soon as that node is added to the scene tree, then that floor stop on slope value would be set to false instead of true. So I'm going to take that out because it's not really relevant. But that's just kind of the idea. So this constant speed thing, you could access that as well. These moving platforms, you could add that as well. This collision safe margin, you could change that as well. All of that. Okay, so with the script, you can again attach one script per node. You can extend the node's class and access its properties and methods. And then with those three methods that we've already talked about, you initialize in ready. If you're going to move the thing around, do it in physics process, and then other stuff just in process generally. Okay, so this is the code that we already looked at and we imported. That was just default. For Godot, there's a few different languages you can use. GDScript is the native language that has been created for the Godot engine specifically. And this is assuming that you're pretty new to programming, or at least pretty new to game programming. And if that's the case, you should really just stick with GDScript. It's going to be very easy to use. It's a very lightweight language. Um, Now, you'll hear online, well, GDScript is interpreted, so it's not very fast. So we want fast languages for Godot or for a game. Well, the thing with Godot, though, is the entire engine itself is not written in GDScript. Most of the game engine is written in C++, which is very fast. When we're using GDScript, typically what we're doing is accessing member methods that are actually themselves implemented in C++. Now, this looks like GDScript stuff, and that's because that's just the interface to the C++ code. How all that works is kind of beyond the scope of this tutorial. If you get really deep into programming, you can kind of figure all that out. Otherwise, just know that these member methods, they're provided in a way that looks like GDScript, but in reality, the stuff under the hood is implemented in C++. So any of the really hardcore, like really detailed programming stuff that needs to be done, that's going to be done in C++. For our scripts that we're attaching to nodes, those aren't going to be super processing heavy typically. So even if they are interpreted in a GDScript language, it's going to run just fine. So as far as how GDScript works, if we're going to declare a variable, we can either make a constant, and then we typically by convention make constants uppercase. So we do constant name, and then if you wanted to add the type, you can do :type. GDScript is not a strongly typed language, but you can give it type hints by saying this would be a float. And if you want to use a variable that might change over time, then you use var, give it the name and the type. To declare functions, you use func and then the name of the function. And then if it's going to have a return type, you can give it a return type with this arrow. So it's good convention to specify the return type, although again, GDScript isn't strongly typed, so you can leave that off. It'll just be inferred. But for your own sanity, it's a good idea to say what the return type is. So again, is GDScript too slow? Mostly no. The engine itself is written in C++, and all the native functions are written in C++, and scripts are just there to call those engine native functions. Okay, so we've already done this basic 2D platformer. So we've already got all this stuff done. There's the character body 2D with a collision shape and a sprite and the world, and we could add walls. And we've got this background mesh. We don't have the sprite. And we instantiated the player scene. Now for 3D, this is going to be your task, is make a basic 3D platformer. The 3D and 2D engines, they are different, but for the most part, things are going to be the same. Now, a couple of things that are going to be different, and you're going to have to read the docs or look around online as to how to do this. So in our 2D game, we could see without adding lights or a camera or anything else. In a 3D game, you're going to have to add some sort of lighting, like the world environment, and you're going to have to explicitly add a camera. We're not just going to have this sort of viewport natively in a 3D game. Other than that, though, most of this stuff is exactly the same. So you can make a character body that's just a capsule. You can give it the collision shape. You can give it the mesh instance. It'll have that native code that's just included right in there. Static bodies, it'll give you all that same stuff. So on your own, use what we've talked about in 2D and implement a basic 3D platformer. Now, the next video in this series is actually going to be my implementation of the 3D platformer, sort of kind of base like this 2D platformer. So if you are struggling, you will see the way I would do it based on what we've done so far. But give it a shot on yourself, see how far you can get, And if you get really, really stuck, you'll see how I would do it in the next video. So thanks for watching, and I will see you in the next one.